All right, so welcome back into our snowy land. So I have a problem with this week. A third of the class didn't turn in an assignment. And that double counts against people because we also use that in the discussion board, so you lose points in both areas. The other problem I have with the discussion board is some people put it into the wrong forum. So if yours disappeared, I want to make sure we're in the right discussion board, the right week, we've got the right homework, and we're going to go over some of the basic pieces that somehow are getting missed. I put in a lot of videos, there's a lot of help. Some people are going out on the web and finding materials, and that's great, but you're also finding materials to the other version of Python. So one of the things I keep seeing repeatedly is people are grabbing code off of the web, and that's great. I want you to go out and find and use those resources. But when you grab code for version 2.x or the older version, it is not going to work in the latest version. So if you have anything called raw input, that's kind of the giveaway that I know that you found code out on the web for 2.7. The programming concepts are the same, but the content itself, that syntax is a little different. So the print statements are different, the input statements are different, and it is not going to run. So if you turn in material, but you haven't actually run it and it errors out, then there's a problem. So ask for help. I try to respond as quickly as possible, whether I'm here on campus, somewhere else, I come off my phone. But if you turn in material and you go, I just couldn't figure this out, and that's what you turn in as a submission comment, and you turn it in at 10 o'clock or 12 o'clock, the day it's due, I can't help that. That I can't help with. So one of the keys is starting early. And I know that's hard to do, and some of you have time constraints, we all do. Well, you need to find time to work on these, not just turning it in. So if you did not turn in the homework, I have actually extended the deadline with a slightly reduced points till midnight. So what that means for you who did turn in the homework, do not post in week 12 your homework submissions yet. So I'm going to hold you off for a day submitting your homework submissions in week 12. So that is week 12. And for whatever reason in the discussion board, and I don't quite understand this one yet, but I have reset this 100 times. I can move this up. So if you want to see an interesting thing, I moved that up. Now it's week 11, 12. There is a coding issue inside of Blackboard. If I come back out of here and go back, so we can clearly see it moved. I go back to the discussion board. Notice it went back to week 12 ahead of that. So I apologize for that if that caused some confusion. I apparently don't have the ability to fix it. So this was the assignment for week 11. This one is for the coding assignment for week 12. So this is the one where you put in the 15 words and you have to scramble them and then you have to add words to that content. So make sure we post in the correct one and post constructive comments. So saying good job isn't really constructive. Saying, hey, if you would have changed a line here, this might have made it more efficient. And some of you are coming up with some really clever, slick things. All of you have that ability to do that. And looking at that code and analyzing it, because quite frankly, one of the things I don't think most of you are going to do is be coders full-time. I don't want to do it full-time. It's not something that I would enjoy sitting there coding every day. But do we get chances that sometimes we have to interpret what's on a website, what's on a piece of code? Yes. And that gives us that ability now to look at it and we can see what's going on. And we have that formulaic thought of, how do I solve a problem, whether it's in Python, whether it's in Java, whether it's in just writing it down, how do I solve those kinds of problems? So hold off until tomorrow morning to post in the week 12 discussion board. And Mason, I've already cleared yours because I know yours was one of them. You posted in week 11 for some reason. Yeah, so I cleared it. And I know it's confusing because at week 11 and 12, for whatever reason, Blackboard has decided we're going to flip the order of those, and I can't seem to fix it easily. So make sure you post in week 12. So this is going to be I have a list of words, and I have them scrambled. how do I come back and I fix those? So the scrambled words idea, and my originally planned, usually as I come in and we talk about the homework previously and we show some examples, but since I'm giving some people a few more hours or hopefully time enough to get that done, we're going to look at some other ideas, and we're going to look at what might make your life a little easier, and that is this level of abstraction we're going to add with defining functions. And we've used functions. You use functions every time you fire up Excel. So when I fire up Excel and I put in the function sum, you're calling a function. You don't have to write the logic behind, I need to add up this row and this column and these cells, but you're using a function. So we're going to find something very similar. So if you look at page, whatever it is, the beginning of chapter 6, we're going to define a function. And so I'm going to look at page 161, and we're going to create, and kind of the structure on this chapter is the idea of we're going to create something like a tic-tac-toe game. We're going to create the logic behind that. So we're going to look at page 161, and we're going to create a function. And a function is really great because I can reuse it over and over again. So if you think back to the code you've already done and you've looked at, like the Hangman game, for example, it called things or reused pieces of code, and we had to copy and paste them in there. And that works, but it starts to get kind of ugly. And what we want to do is make life easier for all of us. And so we're actually going to create our own function. And so where did I put idle? So I'm going to start a new file. And again, one of the things, some people still didn't put in your name and content, so make sure you have your name, and the assignment. In this case, we're going to do a tic-tac-toe. So we're going to create a function, and these functions are going to be handy. We're going to call a function just like we do in Excel. So if I wanted to call a function to a sum, I do sum, and then there's pieces that go inside of that, inside those parentheses. Well, we're going to create those functions on our own. So the first thing we're going to do is we're going to define a function, and we use DEF for define, and we're going to call this one instructions. So once again, it's blocked, and so notice that colon tells the interpreter here to move down and indent. So it's that block of code. And so these instructions then are something we can run just by calling that function instructions. And so we'll tell you about a few other pieces as we go in here. But we can then call this by simply saying, I want to run instructions. So if I come down a little further, so anything I put in here is now instructions. So maybe I put in here a print statement, and that print statement says, welcome to the greatest game ever. Whatever piece you want to have in that instructions, everything in this block is now part of those instructions. So we're now getting some content. If I look at the book has a great piece of content, and I'm just going to copy it because it's got a bunch of triple quotes. So, same indent level, and it says, welcome to the greatest intellectual challenge of all time. The battle's about to begin. And so it starts out showing you how to play tic-tac-toe. It's got all these instructions, and it's not part of our mainline code. We don't necessarily need it as mainline code. So, down here, I'm going to make another comment, And I'm going to say this is my main program. And so in my main program, I want to call the instructions. I want to force it to run. And so it's really easy. I type instructions. And open and close parentheses. We're not putting anything into that function and we're not getting anything back. All we're doing is saying we want to run that instructions. So if I were to save this and run it, let me go up here and find a place to save it. Documents, Python. So I'm going to call this instructions. So now if I run this and I type right, it would be kind of handy. So if I run this, what this does is this calls this function. So anything up here. I don't have to put all the content down here. I'm calling this function. And I can call this function many, many times. So if I make sure I have it spelled correctly, and I hope I do because I can't really see on this thing. Chunk. All right. F5, yes. So all it does is it runs that instructions piece. So if I want to do this multiple times, and this is kind of silly because we're just the instructions, but instead of redoing all of that content, I don't have to copy and paste all of this in here. I can run, and notice it did that however many times I said to do it. 4 times, 5 times. So you can create content by simply saying, I'm going to define a function, I'm going to call that function. So think about those things we've used before. We've used a input, for example. We said we know we want an input from a user and we want to get a specific value. We can reuse those kinds of things again over and over and over again. So one of the other things I see people forgetting to put in is this input at the bottom again. So I saw a lot of those when people turned in code that they didn't put in that input. And let me show you the difference or why that's important. So if I run this program, not through the editor, because most people who you want to send this game to, they can run this game. They don't need to have idle open. And so if I come in here and I try to run this game, right now as it sets, so I'm going to save it, this is what they're going to see. Well, crud, hold on. See if there's any way I can force it to do that. No. If you run this, and it pops up in the other screen, and I don't have any way to record that, unfortunately. It pops up a text box and says, "Oop, I'm out of there," and closes. We don't ever actually, it doesn't hold that program open. If I add in this line, this input, so in other words, it stops the program waiting for you to put in some input, you're going to get this then. And so now it stays open. That program doesn't exit. So before, it would show all this, and because it got done with this, and then it said, I'm going to close the window out, and it closes automatically. So if I just double-click on a program to run it, I can do that. And naturally, it pops open in the other window here. But if I don't have this line in here, it goes away. And you don't even know that the program ran. If there's an error, anything else, you don't have any way to know that. So normally we run ours inside of idle, but if you want to send it to somebody to run, they could actually run it just off the code without having to have this idle window open. So if I change any of these, notice I can delete that. Now it's going to run one time. And I can reuse this in multiple different pieces. And so here in a couple of weeks, we're going to show you how we store all these off in a file somewhere. We don't even need them in our mainline program. But our mainline program, all we have to remember now is we say, yep, we're going to call instructions, and that's our program. So it makes it abstract, a little easier to deal with. And you could have, if you're going to break up your coding structure, So you could have a programmer working on these functions, and as long as you have the same name, you say, I'm going to run the instructions, I'm going to run the game, I'm going to run the ending state. So you could create all of those really, really easily. So it's something called abstraction. So on page 162, they look at the idea of abstraction. That idea of all I need to know is I'm going to run the instructions, and then maybe I had a function for the game. Now I haven't built one, obviously, so it's going to error out if I tried to run that. And then you could have ending credits. And I might reuse those for different games. Maybe the ending credits are the same for every game I write. Thank you for playing another great game from Steam or whoever. And so we're going to break these things into functions. Now our main program is really only those 3 lines there. So that hopefully makes life a little easier as we look at these. So we want to take this program, and I'm going to change it a little bit. Receive and return. So I'm going to now call this receive and return. And so I'm going to get rid of these 2 because we don't need those yet. But I'm going to leave the instructions in there. We know that we can call instructions. We know that if I call those instructions, it's going to run. But I need to be able to get information out of and back into my function. So just like I do in Excel, I need to be able to get information in and out of these. So this one doesn't take information in, doesn't return any information. But I want to do something a little more complicated. So on the top of page 165, or 163, sorry, we're going to create a couple of functions. And so the first one we're going to create is called display messages. Display. And notice message goes into those parentheses. So that's different than what we did here. And all we're going to do is print message. So this function is going to take in a value called message, and it's going to print it. It doesn't do anything else. We're just going to show you how we can pass information in. So I'm going to call that function the same way I did before. So I'm going to say display. And then inside of those parentheses, I'm going to put in a text message. So here is a great message for you. So what this is going to do is take that text and send it into this. And I'm going to just use my comment block. So now I have 2 functions up here. I have instructions and I have display message. And so now if I run this, here is a great message for you. So what it has done is taken that text and sent it up into my content. So it could do the same thing. It could do the same thing if I had a variable in there. So if I were to change this, and I would say, let's just call that mess equals, and I'm going to say, here is a message for you. So in this case, I don't need to put in the string directly. I can put in the variable mess. So now if I run that, what did I do? Probably have a quote. Oh, I have a parenthesis still up there. My bad. All right, so now if I run this, it says, here is a message for you. It took this value that was assigned to mess, put it into display, and passed it up in here into this function. But that's confusing because notice I have a variable here called mess, and my function here has a variable called messenger, right? Isn't that interesting? It doesn't have to be, and in fact, you don't want it to be the same variable because you're not passing the variable, you're passing the content of that variable. I could use the same name because this function doesn't know what this variable is, and I can prove that really, really quickly. So if I were going to pass in this variable, you would think, all right, I need to do that. But if I change this function, so I don't send it a variable, and I just want to print something, I'm going to say, well, I'm going to print mess, because I said mess is equal to a message. I'm not going to pass anything in. So now, if those variables, if you could see them everywhere, if they were a global variable, this would print out, wouldn't it? So let's see what happens. And so luckily for us, because Python says, all right, it's a global variable, it actually does. We haven't set it to private. What we want to be able to do is pass only that information into it. So mess. And up here we're going to GE. And we're going to take in message. So we can send values in, and we can send them in either by value or we can send a variable if it's a global variable. But there's a lot of times we don't want a global variable. So why would we not want a global variable? If I'm going to send in something to print out payroll checks, do I want a global variable for things like Social Security numbers? No, because I don't want those accessible throughout the entire program. So we can also get information back out of functions. So maybe I want a function and I want it to send me a value back. Maybe I want to do some kind of a math function. So I'm going to define another one. And we'll just call this the give 5 function. And give 5, when I define it, I'm not taking any values in. So it's just give 5. And the function then is going to say 5 equals 5. So we have a variable. And then we're going to use the keyword return 5. So to call that then, to call this function then, I'm going to say number is equal to my function. So I called it give 5. So I don't have anything in these parentheses because I'm not sending anything back to the function, but I am using the equal sign. So I have to assign it to a variable. And then I'm going to just do a really quick print number from the function is number. Now we can run it. And so here's a message for you. So it sent that through. And then the number from the function is 5. So it took this value and returned it back down to me. Now this one's kind of silly because we're not doing a whole lot with it. But we're showing we can pass a value back in and we can pass a value back out. So what if we put a value in? What if we said we're going to pass a value? So maybe we need a sub number. So we're going to say sub equals 5. And I'm going to put in sub. And up here, I'm going to take in a value, and I'm going to call it subtotal. And I do assign a value here for 5. So maybe I take and I say whatever value we want to pass back out. So 5 is equal to 5. And then so 5 equals 5 plus subtotal. So whatever number we pass in here goes up, gets added, and then we output another one. And so we can check it, see if it'll do both ways. So it returned the value of 10. So it takes, come back here. So it passed in a value of 5, did some kind of math function with it, and gave us a result back. And this variable, this return, that variable, we don't pass that variable back, we pass just the number that it had in it. So we could create functions, we could create math functions to do all different kinds of things, and we could pass that back all the time. So here's one that's really kind of a handy one to use. We ask this question all the time. We say, do you want to ask yes or no? And so we know that we need a little clarification, so we could define one called ask yes, no. And so in this case, ask yes or no, we're going to bring in something called question. So we're taking in a value. And the first thing we want to do, we're going to use our Boolean to say none. So response is equal to none. So before anything else happens, we're going to say response is equal to none or a false in Boolean. So we can write a loop in here. It doesn't have to be just a set of statements. So while response not in, and so notice we're not in, I can't spell, not in, and now we're going to make a list. So yes, so we're doing a function here. Notice now we come in because we're doing a while loop. And so we say response equals input question dot lower. So we use that lower function. So we always have lower case. So what it does is it converts our question then into a lower case, whatever we have in there. And then we're going to return response. So this is something we do all the time. We get yes or no questions. We ask questions of our users. Well, now we don't have to do anything other than pass it into the function. So instead of having all that code every time in our mainline code, all we have to do, so I come down here in my mainline program, and maybe I say answer equals, and I'm going to call this function ask yes, no, and this is the message I'm passing in. So please enter Y or in. So it passes this content back up, comes in here, and we get a cleaned up version of that yes or that no. And this will loop until they answer yes or no. You could add other functions in there. So you could have it you could have it check or return other things. So make sure you've looked at that on page 164 and 165. So we can return and get values in the same way. So 165 talks about that. And then we define that question and answer piece here on 165 and 166. So we're leading to the idea, I'm going to reuse this over and over again. So if I have a game, I ask questions all the time. Or if I have a program, I ask things like yes or no questions. This can clean it up. So I could write a routine here that I could clean this up really, really easily. So one of the things I want to make sure you guys all see, and in this course documents, if you guys want to see the code, you need to type it. You need to practice. You need to work in the book. But nothing else works. You can't get it to work. Right here is every one of these programs out of the book typed in this area here. So you have them available. That's great, but if you're not working along and practicing these and trying new things, you're also going to run into a little bit of an issue with that. So if I run this game or program, so it gives me a value back. Please enter a yes or a no. So if I type in the value 8, it's going to loop. Now, we didn't create any escape until you hit the right value. Thank you for entering yes. So we could probably clean that up some more, and we could clean that up so that it would, after a couple of responses, you could say, you apparently are not reading the instructions. Please enter a yes or a no. So you could do all kinds of things with it. And this happens every time this function runs. So all I have to do is ask for it here, and I call that function, I put in whatever verbiage I want, and maybe we know that that's the verbiage we want every time, but we can also change that at any point. So now, anytime I want a yes or no answer, instead of having to rewrite all this piece here to verify it, make sure it's lowercase, I just copy this, my call to my function, and I can run that. And I don't have to run it with the same name. I could actually do this. Maybe I need two separate ones for some reason. So I'll call this answer 2. And this will run the same way. No, yes. So you could have different things in there very easily. So imagine here, if you are a smoker. So maybe we're creating a list of please enter if you have used gloves. So now I run this and ask a question. Please enter yes or no if you are a smoker. No. Have you used gloves? Yes. And we've created a whole list of those. So now this makes that easier. I don't have to go through and redo this every time. I'm not reinventing the wheel. I'm reusing software, reusing the stuff that I'm going to do. So the reality is we do these kinds of things programmatically. And maybe we want to put other constraints in there. Again, this only loops, and it'll loop forever. But we could have an escape out where if they didn't do it within 10 times, it errors out and causes some kind of an error condition. So now our main program, instead of having to have any of these pieces, we only have a few things. We have, here's answer 1, answer 2, and you could create an entire list of those really, really easily. All right, so on page 167, we're going to look at something called birthday wishes. And so birthday wishes tells us a couple of pieces about how we're going to pass in information in a couple of different ways. So I am going to actually, for right now, I am going to do a whole new one. And this new file, so I'm going to call it birthday wishes. And what we're really looking at here is positional and default parameters. So we're going to define a couple of functions. So we're going to define birthday 1. And so birthday 1 is going to take not just one argument, but 2 arguments. So it's going to take a name and an age. And so maybe we're writing a program for whatever the Happy Jack Flaps, wherever the mouse, Chuck E. Cheese's lives or something. And so we're going to take in a name and an age, and we're going to make a print statement that says, Happy birthday, and put in name, and maybe some exclamation marks. Bless you. So remember, we separate those with commas, and then we're going to put in, I believe you are age so I'm just creating a little bit of a statement here that says age, and so you could put in all different kinds of things like our book says today. So I've got a print statement here that takes in the values and says I'm going to print this out. So I'm going to come down here, and I always want to get in the habit of doing this now. I want to put in main, so I can separate where my functions and my main pieces are. So I may put up here, I may even put functions. So I'm just kind of blocking these out in different things. So my main, I know I can call this, and I can say birthday 1. And I don't have to set it equal to a variable. I'm not getting anything back. And I could say, just because I'm going to pick on Mason, that Mason is suddenly 14. Was a good age. So if I run this, and I'm going to call this one birthday. So it's going to say, happy birthday, Mason. I believe you are 14 today. And so it took those two variables and passed them up into that function. Capitalize happy because that'll drive me crazy. So I also want to create a second function. And the second function is going to do something interesting. And the second function is going to have some defaults in it. So I'm going to call this one birthday 2. And I'm also going to pass in name. And in this case, because I'm at Chuck E. Cheese's, maybe we're going to consider everybody Chucky. So it's got a default name of Chucky, and it's had a default age of 5. So if I just run this function, and I'm going to then copy my statement I had above, down, and I'm going to copy this print statement. So I have two functions, just so we can see what's going to happen. So right now, if I change that one from birthday 1 to birthday 2, let's see what happens. I'm going to save it. And so it calls birthday 2, but wait a minute, let's look here. I said that the name in here, the default was Chucky and age 5, but when I passed in a value, notice it overrode it and it put Mason and age 14. So I'm just curious what happens if I only pass in one variable. What's going to happen? And so it says, happy birthday, Mason. It got that. I believe you are 5. And so it took that default right there out of my argument. Well, we can also do some other pieces with it that are kind of interesting. So we're gonna play around here a little bit. So I'm gonna go back to my first one. We know we have two functions. Happy birthday, Mason, but we don't put in anything else. So let's see what happens if we run that. And it's going to error out because it doesn't have that second argument. And we call those positionals because we pass in variable 1, we pass in variable 2 based on position. So that isn't going to work in this case because we don't have those defaults. So these defaults could cause us some protection or give us some protection. And so you could come up with, hey, customer, we think you're age 29 or whatever it is. So we're going to do a couple of other ones here and see what happens. So maybe I don't know the correct order and I pass in 16 and Mason. So now I'm going to run that. Hello? There we go. And it's going to say, happy birthday 16, I believe you are Mason today. So and notice it works on the idea of that position. So if I pass in two variables, it's going to use them in that order. So 16 becomes name, Mason becomes age. So they're position dependent. But maybe I have some other ways I can do it. So I'm going to call this function again, birthday 1. Well, now I'm actually going to reference that name in there. And I'm going to say name equals, who else can I pick on? Kayla. And then I'm going to say age equals 21. And so now let's see what happens if I run this. And it says, happy birthday, Kayla. I believe you are 21 today. And so I can put those in. Well, let's just flip it around and let's see what happens then. Does that override that positional issue? So I'm going to say age equal, let's put in 13. And name equals Mark. So now let's see what happens. We flipped them around. So positionally, this is wrong, but we assigned a name to it. So let's see what happens. And it actually, notice what it did. It says, oh, I know that name goes in here, age is here. So we can override those positions. Now, I will say most of the time we don't go to this trouble. We know that we're in the right positions and we just put them in the right order. So we can play around, and those are the kinds of things that it's interesting to do and to see how these functions are going to work so you understand that a little better. So now if I do the birthday 2, and I just pass in nothing, no values at all, notice it says, all right, it gives us our happy birthday. Chucky, you are age 5. But maybe I don't know the name, but I can pass in just a piece of it. So birthday 2, so name equals Chris. And so I can see if what's going to happen there. And so it does. It says, Chris, it took that in. I believe you are 5 today. So it only took in the piece it knew. But again, if I try to just do one of them without that name, we're going to end up with a little bit of an issue. So we can pass in and we can override this. So Chris overrode Chucky. I can put them in this way. So birthday to age equals 47. Name equals old dad. And so now I could run those. And it says, old dad, I believe you're 47 today. And so if I specifically call out that argument, that keyword, then I can pass those in any order. So it's another way I can use those, and I can override those. But by putting in that default, if I make an error, it's going to come in here. So maybe I would change that then to customer and age 5. And it would depend on your business, obviously. But now, if I just ran this, down here it's going to say customer, or you could put in our valued customer or something like that if you're doing a cash register. So that gives us a lot of different ways we can put in data into those functions. So we can override those defaults. So again, it's just a best practice. I'm going to create a function. I can create those, and I can do that. So on page 171, we start looking about scope, and we look at global, and we look at local variables. So earlier, when I declared a variable, it was available in the function, and it was available in the main. So here's our main program. I can declare global variables. And so there's a little chart on page 171 that maybe makes it a little easier. So in this case, variable 0 is available everywhere. So it's a global variable. Variable 1, the variable I define in a function, and variable 2 are only available inside of that function. So that scope of that variable depends on how we create it. So there is a program that we're going to create called Global Reach. And global will hopefully help us identify where these pieces are and how they're working. So Global Reach, we start the code actually on 173, and we start looking at it. So we're going to create a new one again. So I'm going to delete this birthday wishes one, and I'm going to do a file new. And so we're going to try to see if we can make this a little more understandable. So we're going to create what we're going to call Global Reach. And remember, a global variable is available anywhere, in a function, in a main, anywhere. So I know I'm going to have a section up here called functions. I know I'm going to have a section here called main. And so now I can start breaking up my programs. And we're going to start making this idea of a global program. So I know at the bottom of this I need an input to hold this guy open. So chunk, chunk. So our function, our first function we're going to do is we're going to have one we're going to call read global. So we're going to call this define read underscore global. So functions are really and so we're going to then put a print statement in from inside the local scope of read global, the value is, and we're going to grab a variable called value. So we need a comma and then value. So this print statement is going to try to read something called value and print it out. And so if I run it right now, it's going to say, all right, press and enter the key to exit. Now, that's interesting. Did it do anything? It's all in a function up here, so it never tries to run this unless we tell it to. So it just hits that input and says, nope, nothing to do here. So we can create all the functions you want, and until you call them, they're not even going to cause an error for you. So unless you call a function, I'm not even going to know if it's got an error or not in it. So from the main, I'm going to say value equals 10. Again, I still could run this and I'm not going to get anything because I haven't called that yet. So I'm going to put a print statement in here. In the global scope, the value has been set to value. And so now it's going to print out the value. I still haven't called the function yet. So in the global scope, the value has been set to 10. Okay. So now I want to call that function. So I'm going to call read global. Notice I'm not passing anything into it. All I'm doing is causing that function to execute. And so now, in the global scope, the value has been set to 10. From inside the local scope of read global, the value is 10. So it's pulling that value here. We have that value is set to everywhere. And again, sometimes that might be interesting, but let's do a little more here and see if we can do some interesting pieces here. So we're going to create another function, and we're going to call this shadow. So shadow global, and shadow global is going to set a value equal to, and let's call this one minus 10. So we've set the value to minus 10, and then we're going to print, I'm just going to copy this and make a quick change on it. Because again, I don't want to reinvent the wheel. So from inside of this function, it's going to use value is set equal to 10. So to do anything with this variable then, I need to call it. And so I'm going to call it, and I'm going to say, all right, I want to call shadow global. So whatever I called that function. And so when I run this, let's see what I get. So it says, in the global scope, value is set to 10. So here, that didn't change. From inside the local scope, it's 10. From inside this variable, this function, it's going to print out the value, and it's going to say, oh, it's negative 10. But if I do a print, so I'm just going to copy and paste this down here. So it's going to look at, in the global scope, the value has been set to 10. So I'm just going to run this again. And so if this truly changed the value, let's see what happens. So it says inside it's 10, outside it's 10. So we've set it globally. We tried to change that variable from inside a function, and it said, yep, it's negative 10 inside of it. But when I printed outside of that global scope, it didn't change it. So notice I could read that variable, but I couldn't change it. So it didn't change that value of 10 then. So I need a way that I can set these all up as global variables, and I can change them then inside of there. So I'm going to define one more function. And I'm going to call this function change global. And I'm going to make one more change. I'm going to use the keyword global. And notice it highlights it, so it says, oh, it must be a keyword. And I'm going to call global value. So I have now set whatever that value in is global as a global value. So value equals minus 10. And from inside in the global change global, the value is now set to negative 10. And then I'm going to have one more. So I'm going to call it again. So I'm going to call change global. And so when I call this function, it's actually going to come up here and it's going to assign that as a global value. So now I'm going to see if that actually did change my value in my main program. So it didn't change it up here. That didn't change. But notice here, when I defined that as a global value, and I use that keyword, now I can access that value inside of a function, and I can change it. So now it's a little scarier. I can change that inside of that variable. So we went through all this, and I said, great, now we can change things inside of functions. And I'm going to tell you this is a really bad thing to do unless you absolutely, absolutely have to. So I want to limit these. So where I would use these are things like constants. So if I had something I needed in every function available and every piece of the program, and it wasn't confidential, didn't have things like, you know, if I'm in a hospital, have patient data, or if I'm in a college, have student data, I could probably use these. So they do give us some advantage. And so now I want to create a game, and I want to create a game about tic-tac-toe. And tic-tac-toe, I want to break tic-tac-toe up into functions. And so I'm going to do something, and I want to create a list of functions inside here. So I want to logically kind of break this up. So the first thing I want to do is I know, and I'm going to write this kind of in a pseudocode just so we have tic-tac-toe and we can break it out. So what's the first thing we would do with a game like tic-tac-toe to a user? What are we going to show them first when they first get there? Well, I'm going to say we probably are going to display instructions. So we're going to display instructions. And if I have either the computer or a person versus a person, one of the other things we have to do is we have to figure out who goes first. And in a lot of games, who goes first has a great advantage, and certainly in tic-tac-toe. So we might say we're going to determine who is first. Well, the next step, we want to display a board. There isn't going to be anything on there, So we're going to display our empty board. Well, now it gets a little more complicated. Because now we've got our board, we figured out who goes first. Now we need to create the mechanism for you to play the game. And in tic-tac-toe, we know there's only a maximum of how many turns? 9. So we could write it down each step, or we could do it with a loop. And so we're going to create a loop, and then that loop is going to say something like, while nobody has won, and it's not a tie. Because if you're already tied, there's no reason to go on. And because we're doing a loop, now we're going to break in here, everybody. And we're going to break that code out. So these things all happen inside of that loop. And so inside of that loop, we could do a set of if statements. So our first if statement might be if human turn. So if it's the human term, get move, and then we update board. So we could then say else, or otherwise, or whatever key phrase you want to use. But we know in our code we're actually going to use an else statement. So else, we know it's going to be the computer's move, so we need to figure out computer move from algorithm. So in other words, how did we figure out what's the best move for the computer? And then once again, we're going to update the board. So our loop then will go through those pieces. So now at the end of this then, we need to display the board. And we have to have some way to switch turns. So in other words, if we hit this stage, we flip back and forth. So if it was the human move, and then finally we want to have maybe a congratulations. Well, a lot of these could be written as functions. So right offhand, I think, all right, I'm going to use display instructions is going to be a function. Congratulations could be a function, so we get them out of our code. So our mainline code is going to look very similar to this. It's going to do a couple of these pieces, send it off up into the function. So I don't have to think about all those individual steps about like asking for a move. I have a piece of code in a function that I'm going to do that with. So on page 177, we actually have a list of functions. So they took this idea of what are we going to do here and created a list of things they need for functions. And if you look at the top, display instructions, the bottom, congratulate the winner. So we have two functions we knew of from here. They have an ask yes no, which is one we've already created. To receive a question, returns either yes or no. We have an ask number, and so that one asks for a number within a range. And so you can ask of a certain range what you want. Pieces, so they wrote a function called pieces. And pieces says determines who goes first. New board creates a new empty board. And notice what they've done. They said create and returns that board. So we also are starting to look at which one of these functions return things. So notice it says the function name that it's got the return as board. So we're also starting to create a dictionary of the terms and the variables we're using. So legal moves creates a list of legal moves, receives a board. We have winner that also uses board. Human move, so gets the human's move from the player, receives a board and the human's piece. Computer move, very similar. Next turn. So next turn is the function that switches from whether we're playing or the computer's playing. And then we have that congratulate the winner function. So on page 176, we look at, here's a typical board, 0 through 8. So in other words, 9 positions. So we've labeled them because the computer works numerically. It doesn't work graphically. And so we're going to build this, and we're going to do this all with the idea of functions versus the idea of just discrete coding. And so when I look at this entire program, we're going to have really very little in the main program. So the main program is actually going to be one line. So our entire main program is this. We're going to put the entire program into functions. And so we're going to call a function called main. And so you see this is a pretty common structure we do in Python and in fact in a lot of programming languages. So the entire program is that. Or maybe we'd like to look at it this way. And so your entire program would look like this. We're going to start the program. It calls a function called main. And notice we don't have main on our list. So the main is the idea of what we're going to run. So main's going to call a set of functions. And so I'm going to put it up here really quickly. So we see what it is. So main, let me scroll down just a little bit. We call it, it runs main. So kind of like our pseudocode up there, it displays the instructions. It runs, it passes in computer and human are equal to pieces. So in other words, we figure out where they land in that order. We have turn. So here we have turn equals X. Board equals new board. So in other words, we're calling a new board. And we're going to display, so we get this value for board. We immediately pass it into this display, and we show the board. This should look very similar to what we just talked about. So while there's not a winner, we have these set of if statements. So if turn is equal to human, we're going to move the human board, else the computer gets to move. And then this one flips the next turn function. So, could we write this program without functions? Yeah. But this gives us a way we can recreate and reuse things. So our ask yes no function, when we ask questions about do you want to give up, do you want to do anything, that yes no function, we're going to use that in a lot of code. So that very same function we're just going to reuse. So our ask yes or no function looks like that. Ask for a number within a range. So it passes in a value of question and a value from low to high. So if we suddenly decided to expand this game to 4x4 squares, I'm not sure how that would work yet, but we could pass in the same question and a low and a high range. And so this we reuse over and over again. We don't have to have it in our mainline code. All we have to do is have that function that references it. All right, so on Thursday we're going to build this tic-tac-toe. We're going to look at those functions. Make sure that you have turned in an assignment for week 11. Tomorrow you are free to turn in on the discussion board for week 12 your code for last week. In other words, that how do I take 15 names, scramble them, add names, re-scramble them, and display them. So this week we're going to look at how we break things into functions. And I think it actually makes life easier. It looks more complicated right now, but when you start to look at your mainline logic as only being one line, it starts to make life easier for you.